everyone, welcome back to Chapter 8. Today I'm going to be talking about 8.2, which is polygons, and we're going to look at sides and angles. So a polygon is just a closed figure in a plane determined by three or more straight line segments. You've learned about polygons before, so triangles, squares, rectangles, decagons, pentagons, and those things. They're named according to the number of sides. So in letter A, we have a four-sided figure. We would call that a quadrilateral. The prefix quad means four. In letter B, we have an octagon. There's eight sides. So oct means eight. In letter C, we have five sides. So that's called a pentagon. So you might be familiar with the Pentagon in Washington, D.C. It's five-sided. And then in letter D, we have our triangle, which is three sides. With the prefix tri means three. Some polygons have all the sides that are the same length and all of their angles are the same measure, and we refer to them as regular polygons. So if I was to pick out the two regular polygons here, by just looking, it looks as if it would be the octagon and the triangle because all the sides look like they're the same and all of the angles look approximately equal. So we use triangles a lot in geometry to solve other problems, and it's important to know different properties of triangles. One of those properties is that if you were to add all of the interior angles inside a triangle, you would get 180 degrees. So if I take a triangle, in other words, and I number the angles, angle 1, 2, and 3, if I was to add the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, it would add up to 180 degrees. And that's really important because we're going to use that for other problem solving. So how do you determine the sum of the measures of the interior angles in any polygon? What if we don't have a triangle? What if it's a quadrilateral or a decagon, which is 10 sides? How many degrees would be inside that figure? So there's a formula that we can use, and it's n minus 2 times 180. And n is just the number of sides. So for example, we have a regular decagon. So a decagon is 10 sides. And again, regular means all the sides are equal and all the angles are equal. And as you can tell by looking at the decagon, it looks regular. So what we need to do is find the measure of an interior angle. So in other words, what would just one of those angles be? And the measure of an exterior angle, which is angle 1 in this problem. So in order to figure out how many degrees each of those angles is, the first thing I need to do is figure out how many degrees is inside that entire decagon. So I know that a decagon has 10 sides, so n is going to be 10. So I'm going to do 10 minus 2 times 180. And 10 minus 2 is 8. And I'm just going to multiply that by 180. And 8 times 180 is 1,440. So that's how many degrees are inside this entire decagon. I need to know how many degrees just one of those angles is. So all I have to do now is divide by 10 because there's 10 equal angles. And when you do that, you get 144. So every one of these angles is 144 degrees. Now I need to find my exterior angle. So how many degrees would angle 1 be? So if you'll remember, you've got a straight line here. How many degrees are in a straight line? 180. So if I just subtract 180 minus 144, which gives me 36, that's how many degrees angle 1 would be. So that would be the measure of the exterior angle. Another way you could have gotten the exterior angle is you could take 360 and divide it by the number of sides. So 360 divided by 10 is 36. So every exterior angle would be 36 degrees. Now, why am I taking 360? It's because if you rotate around that decagon, it would take 360 degrees. That's a full rotation. There's different ways to classify triangles. So triangles really have like a first and last name, kind of like people do. You can name them by their angles and by their sides. So a triangle that has all acute angles, remember acute means less than 90, is called an acute triangle. A triangle that has one obtuse angle, remember that an obtuse angle is an angle bigger than 90 but less than 180, that's called an obtuse triangle. And then a right triangle has one right angle, which remember equals 90 degrees. And we signify that using a box. They also use this word hypotenuse, and that's the measure of the side that's across from the 90. So if you find the 90-degree angle and go right across from it, it takes you to the hypotenuse, which in fact is the longest side in any right triangle. You can also name a triangle by its side lengths. So you have an isosceles triangle, which means two sides are equal. You have an equilateral triangle where three sides are equal, and that means all of the angles inside would be 360 because 180 divided by 3 is 60 degrees. And a scalene triangle has no sides that are equal. So you would usually see that marked kind of like this, where you put one mark in one side and then two dashes in the other and then three. Okay, so that's a little bit about classifying triangles. Let's look at how we can use the properties of triangles to determine x. So in this problem, they give us two angles, 132 degrees and 37 degrees, and we have to figure out what angle x is. So I'm going to focus on this triangle right here. Triangles are very helpful because you know there's got to be 180 degrees in there. So we also know that lines have 180. So if you'll remember, if I want this angle right here, all I have to do is subtract 180 minus the angle next to it. So if I do 180 minus 132, it leaves us with 48 degrees. So I know that this angle in here is 48. If you'll also remember, this angle is equal to this one because they're called vertical. So I know that that angle is 37 degrees. Now, how many degrees are in a triangle? I have in that blue triangle, I know two of the angles. One of them's 48 and one of them's 37. How do I get the third angle? I'm going to add the two angles together. So 48 plus 37, which gives me 85 degrees. And then I'm going to subtract that from the total number of degrees in a triangle, which is 180. So 180 minus 85 leaves me with 95 degrees. So I'm going to, since I don't have a lot of room in there, I'm going to put the 95 right here. And I'm going to fill in what we found with the other one. So that one was 48 because 48 plus 132 is 180. And then this is 37 because it's vertical. Okay, so now what's special about this angle and this one? They're also vertical, so they're equal. So x is also 95 degrees. Next, we're going to talk about similar figures. So the symbol for similar looks very familiar, right? We've used that symbol before to represent the word not when we were dealing with logic. So in geometry, it means something different. It means similar. And similar figures have corresponding angles that are equal, but the lengths of their corresponding sides are in proportion. So that word proportion, what does that mean? Proportions are just ratios or fractions. By the way, the word fraction has the word ratio in it. They're the same thing. It's just ratios and fractions that are equal. That's all a proportion is. So to solve similar figure problems, we're going to create a proportion. So we're going to have two fractions equal to each other. So in this problem, it tells us that both of those figures are similar. By the way, what would you call that figure? It has 5 sides, so they're pentagons. So they're similar. Okay, what does that mean? It means the corresponding angles are equal and the side lengths are proportional. So we need to create two equal fractions. So one of the things I'm going to do here is I need to find y. And y corresponds to this side here. So I'm going to take y and put it over 4. I'm going to turn it into a fraction. Remember, we're creating proportions, so we're making two equal fractions. So now, when you create your other fraction, we can't use x just yet because we'll have too many variables. So we're going to hold off on x, and we're going to look for two sides that correspond, that have numbers. So those two sides would be 3 and 4.5. Now, which one do I put on top? You have to be really careful. When I created my fraction, I put y over 4. So that means I have to go back to the big pentagon and put 4.5 over 3. To solve this equation, all you do is cross multiply. So I'm going to multiply 3 times y, and I would get 3y. And then you're going to multiply 4 times 4.5. So I have 3y equals 4 times 4.5 is 18. And then I'm going to divide by 3, and 18 divided by 3 leaves me with 6. So y should be 6. Now I need to find x, and I'm not going to get rid of my orange highlight because those two sides, I can reuse them to find x. So now I just need to find my x, and x right here corresponds to the 3. So I'm going to this time do x over 3, but now since I put x on top, when I create my other fraction, I have to put the 3 on top. So I have 3 over 4.5. And now again, it's a proportion. It's two equal fractions. Cross multiply and divide. So crisscross applesauce, you're just going to do 4.5 times x and then 3 times 3. So you get 4.5x equals 3 times 3 is 9. And then I'm just going to divide both sides by 4.5, and 9 divided by 4.5 is 2. Okay, so what I would like you to do is pause the video and read the try it on your own, and then when you're ready, you can unpause the video and then watch how I would work this out. Also, it'll give you a chance to read it and kind of comprehend what it's asking, which is important. Gabriella plans to remove a tree from her backyard. She needs to know the height of the tree. Gabriella is 6 feet tall and determines that when her shadow is 9 feet tall, the shadow of the tree is 45 feet long. How tall is the tree? So this is known as indirect measurement. You can measure tall objects using this method just by measuring shadows. Since they're on the ground, it's easier to measure. So think of it like this. So here's your tree. Okay, we'll make it a palm tree since we're in Florida. Okay, and it's casting a shadow. And here's Gabriella. Okay, she's also casting a shadow. And what we need to do is figure out how tall is this tree. So we're going to just create two triangles. We've got this big triangle here. Think of this as your triangle. That's your big one. Okay, so that represents the tree and its shadow. So we don't know what the tree is, the height, but we know the shadow is 45 feet long. And then I've got my other triangle, which is here. And that's Gabriella and her shadow. So we know it told us Gabriella is 6 feet tall and her shadow is 9 feet. So we've got two similar triangles, which remember means their angles, the corresponding angles are equal, their sides are proportional. So how are we going to solve this? We're going to set up a proportion. So I'm going to match up my sides. So I've got x over 6 equals 45 over 9. By the way, that's not the only way you could set up that proportion. There's other ways you could have done it and arrived at the same answer. How do we solve proportions? Cross, multiply, and divide. So you've got 9 times x, which is 9x, and then 6 times 45. So you have 9x equals 6 times 45, and 6 times 45 is 270. And then I'm going to divide both sides by 9, and 270 divided by 9 is 30. So the height of the tree is about 30 feet tall. What is the difference between similar and congruent figures? So the symbol for congruent looks like an equal sign with the tilde on top. And congruent basically is the geometry way of saying equal. So it's when similar figures have the same corresponding side lengths. So what's important to remember for congruent figures, they're going to have equal side lengths and they're also going to have equal angle measures, which is different than similar figures. Remember, similar figures have equal angle measures. Their corresponding angle measures are equal, but their side lengths are proportional. In congruent, the side lengths are equal. Okay, so that kind of makes things easier for us. So here we have two triangles, and it says determine the lengths of the sides and the measure of the angles for the congruent triangles ABC. And then when they put those apostrophes there, they're just telling you it's a different triangle, but it's congruent, it's equal. We actually read those as primes. So you would read that as A prime, B prime, C prime. So those are called prime symbols. They look like apostrophes. All it's saying is angle A is the same or is congruent to angle A prime, and angle B will equal B prime, and angle C equals C prime. Okay, so remember, we're dealing with congruent triangles. It told us here they're congruent. So what does that mean? It means the corresponding sides are equal and the corresponding angles. So I'm going to first color code these, right? I've got side AB, and that side will be equal to side A prime, B prime. Then I've got side BC, and that's going to equal side B prime, C prime. And then I've got side AC, which is equal to A prime, C prime. So if I want to find the length of side AB, it's going to be the same or congruent to side A prime, B prime. So A prime, B prime is 33 units long. So that means that AB is also 33 units long. In number 2, they want us to find the measure of angle ACB. So if I look at ACB, here's A, here's C, and here's B. So remember when we talked about angles in the last section, they're asking for this angle right here. That's the vertex. Okay, you could tell because it's in the middle. So they want to know, what is that angle? So I have to work backwards here. I don't have enough information, and I can't get it from the other triangle because they don't tell me what C prime is. So how do you think you could work backwards to figure out what C is? Remember that if you know there's 180 degrees in a triangle, you can figure it out. So they do give us enough information. They tell us that B prime is 78 degrees. So that means that B is also 78. Knowing that, I can now figure this out because I know that in a triangle it has to add up to 180. So I'm going to add up 31 plus 78, which gives me 109. And then I'm just going to subtract that from 180. So 180 minus 109 is 71 degrees. So I know angle ACB has to be 71 degrees. All right, pause the video and try the two problems below, and then unpause when you're ready to check your answer. So using the previous diagram, if I want to find A prime C prime, it's going to be congruent to AC. And they told us that AC was 34, so that means A prime C prime is also 34 units long. And when I'm asked for the measure of angle ABC, here's A, B, and C. They're asking me for this angle here. That's going to be the same as A prime, B prime, C prime, which is 78 degrees. The last thing we're going to talk about in this section are quadrilaterals. So remember, quadrilaterals are four-sided polygons, and now one of the things to remember is that their angles add up to 360. So in a triangle, the three angles add up to 180, but when we get to quadrilaterals, four-sided figures, they have 360 degrees inside. Some of the quadrilaterals are listed here. You've got trapezoids, parallelograms, a rhombus, a rectangle, and a square. So in a parallelogram, they have to have both pairs of sides, opposite sides parallel. And there are three parallelograms. The rhombus is a parallelogram because it's got two pairs of opposite sides parallel. The rectangle is a parallelogram, and a square. So there are your three parallelograms. A trapezoid is not a parallelogram. It only has one pair of sides parallel. So the sides in a trapezoid that are parallel, they're called the bases. So trapezoids have two bases. That would be base 1, and then this would be base 2. But you can see the other two sides, they're eventually going to intersect each other. If I was to keep drawing both of those sides, you can see eventually they're going to intersect. So that's why a trapezoid's not a parallelogram. It's a quadrilateral, it's four sides, but it's not a parallelogram. A rhombus, a rectangle, and a square are parallelograms. So in this problem, we have trapezoid ABCD in the figure, and we have to determine the following. The first thing we need to do is find the measure of the interior angle X. So if you'll remember, there's 360 degrees in a quadrilateral. They give me three of those angles. So I can figure out angle X. So angle A is 130, and the boxes in angle B and C represent 90. So I'm going to add 130 plus 90 plus X equals 360. And now I just need to solve for X. So I'm going to add up the 130, the 90, and the 90, and that gives me 310. And then I'm going to subtract 360 minus 310, and I get 50. So X is 50 degrees. Now try to think about how we found an exterior angle if you know the interior. How am I going to figure out Y? So if you'll recall, X and Y, they are on a straight line, which has 180 degrees. So all I need to do now is take 180 minus 50, and it gives me 130 degrees. So Y is 130. Okay, that's the end of video 8.2. If you have any questions, please email me. Let me know. I'm more than happy to help. And I hope you enjoy the rest of your day or night.